Good morning and welcome to the Innovation Lab Talks, the Thermal Chain Innovation Series, the Europe edition. I would like to welcome you in this webinar focused on the challenges smart thermal chain management faces in the 21st century. So thermal chain logistics is a growing area, and the supply chain area has got a lot of development. And as with all development, difficulties, obstacles, and problems occur and must be dealt with. Therefore, in this webinar, we are going to discuss the challenges companies face in what comes to maintaining thermal chain conditions, how these challenges can be faced, and how they can be surpassed. So we'll start by presenting you with a specific example of an issue that companies and operators face daily in what comes to transporting goods in maintained thermal conditions. And we will go on discussing what solutions may exist, what companies and operators can do, and giving us an understanding what can be the solutions for these issues. Providing us with the intelligent solution that can be used to face these specific difficulties, we will have with us Manuel Pizarro. He's CEO of Advanced Products Portugal. And following, we will have the experts that work on the solution who will briefly explain the science, the underpinning science behind what was developed. So we'll have Ana Magalhães, researcher at the Center of Nanotechnology and Smart Materials, CENTIM, who will explain the importance of all the materials used on this solution, and also Albert Retey, lead developer at SmartKai, focusing on the digital technology involved on the solution, and Cristina Silva, associate professor at the Faculty of Biotechnology of Universidade Católica Portuguesa, and Beatriz Bernardes, who will explain how the solution was verified throughout science. I would like to also let our audience know that throughout this webinar, you can always put your questions in our chat down here, and also I will ask you to direct your questions to a specific speaker on the chat, so we know who do you want to answer to your questions. So I should say that in preparing this session, we spoke with several managers and experts in logistics and thermal chain logistics, and we discussed with all of them what were the issues they faced, what were the problems they faced in their area, in their field area. During these conversations, this preparation, a common situation emerged, a challenge that pharma companies throughout Europe appear to face. It's a very common challenge. So it will be my role today to be the unofficially chosen spokesperson of this managers group, that are almost an advisory group we had here, to present you with the thermal change challenge they chose to this webinar. So when it comes specifically to pharma products, there are product requirements. We have storage requirements for these products between 15 and 25 centigrade degrees, and of course the need for stability, as these products have a high degradation when exposed to high temperatures. Also, when it comes to transporting these products on a continent basis, like Europe basis, the transport mode would be by airplane. And normally transport temperature can be maintained and should be maintained between 15 degrees centigrade and 25 degrees centigrade. The issue arises when we look at the logistic flow of getting these products from point A to point B in Europe. So the products are in the storehouse, and specifically when it comes to temperature control, temperature is controlled during the storehouse, and they go on to a truck that does the traveling from point A, the storehouse, to point B, the airport. And during this travel, this transportation, temperature is completely maintained in the truck. And then it comes to airport handling, out of the truck into the airplane. So airport handling and the tarmac area. And it's not possible to control the temperature, and this is a problem we face. And in air travel, so during the traveling in airplane, the temperature, the product will maintain its temperature, 15 to 25 degrees centigrades again, with stability. And when they land in point B, we have again airport handling, and maybe we have a cool dolly. And of course, in airport handling, it's not possible to control the temperature. And if the airport has a cool dolly, you can control it and maintain it mostly. But if not, this temperature again suffers some changes. And then the product will go again into the truck, and it will face again a controlled temperature setting. So as a summary, we can say that although companies and transportation experts can guarantee thermal chain integrity during transportation to and from the airport, during air transportation, the same does not occur during all the cross-docking operations on the logistics area. So what is the thermal chain challenge? Well, of course, first of all, managers need to understand and to know their products and their requirements and their transport requirements, of course. And they need to choose a partner. They need to know how to choose a partner to trust with this farm achievement. In order to understand and to have a temperature controlled solution for these non-controlled stages of the transportation mainly. And that would be the main issue focusing on this area we're facing. So to understand with me and to let us understand the solution that can be provided, I will pass on to Manuel Pizarro and ask you, Manuel, how do logistic managers answer these issues that they face?
Hello, good morning to all. In our company, this is our solutions is to resolve this challenge. It's what I see. It's a normal challenge. I believe we can answer to that. Innovation is the driver of the companies that their sustainability, adapting the needs of operations are all showing. So getting to the goal, and this is the goal. It was the cool smart cover. I believe when you begin with this innovation, we map 3 scenarios that you have to make improvements. One of them was create in double protection in some moments. In moments when the air transport will be very sensitive to temperatures, which is very necessary and cannot anyway have temperature excursions. Or in other words, safe additional protection. It was what we have in this challenge. No degradation when exposed to high temperatures. Even in active cold, as I see, maybe we have some part of the operation in active cold. In all process, sometimes we have excursions, and the idea is that no variation of temperature. And sometimes there are products that have the stability and the others do not allow it. Solution that created even more security for transport and the cross-dockings for extreme sensitive products. And as I see, we have 3 cross-dockings here. Maybe we don't have it with a cold dolly, but we have to check. But in the challenge is what I see. In the active, if we have some stage with active, sometimes the batteries and the motors maybe have faults. So we need to have time to take an action and to not lose the quality and the investment, and have a backup to solution for these situations. Is one of the idea of the cover is be this backup. And normally these solutions inactive could be by train, truck, boat. As I see here is only truck, airport, and I see we have a problem in tarmac. Yes, I believe we can have an answer too. And another things, using when we developed the solutions, it was to be dedicated lines. As I see in a challenge, I can see here, choose a partner, trust pharma shipment is very important. Pharma is very sensitive products, so we are talking about dedicated lines or dedicated operations. And the cover, I believe, we developed a system that can transport and if it's possible, reuse it, because for sustainable, because we must be economic and sustainable and be traceable. And if you can, localization where the solution is in. When we develop the system, we are talking about more or less 10, 12 hours. Depends on the profile. If the profile is smoother, maybe we can do. What I can see in this challenge, there are parts that are temperature control and the others not. So we have to check maybe if it's a good solution. But it's a solution that I believe is dedicated to point A to point B. We finish the last mile with the truck, is important. And I believe we can do it with no problems. Nowadays, the logistical operational are designed in detail and it's easier to make a decision. I believe we can have here, could be security that I am going to explain in the future, trying to present the answers for this challenge. Another thing, it was important in this when we try to innovate, is being able to have an economical and not very expensive reverse logistic. Integrate a system that monitors and can locate wherever it's possible. As soon as it's possible, it's very important. We can have control and where they are located and minimize loss is important because we have to regroup again the solutions. Normally in these dedicated situations, normally they are authorizing and then they do not have difficulties in your transit and customs. We are talking about direct lines and handled by specialized operators. Right now, as you know, in this pandemic stage that we live here, there is a need to supply as soon as the direct lines are created. We have to supply, and there is a lot of demand. And few means we have to be more agile. Besides, the solution must be to regroup and your system. So what I'm saying, you must have all the synergies that you have in this operation to can do it, because there is a lot of demand of medicines nowadays in the world. Another thing is important to do the reverse logistic, just to compare and see an idea. And here we are talking about reverse logistic in a plane. The idea that when develop this is up to, we can collect 5 units of this EcoPCM up to 140 meters, and the weight you must be 175 kilos, less than 200 kilos. If in the whole, the other systems, his pallet boxes, we can only collect 2 or 3, but the A will be 400 kilos. If you recover with the PCM, it will be probably the triple. Only this cost can make reverse logistics infeasible. And the alternative that we have at the moment is collect more than 10 units and collect them per boat. Too long and continuous lines, it's too long to continuous lines. Depends a lot of time. So if I can now, I can using my slides, please, just just to present what was done. We try to create intelligent solutions. I don't know, now I know the challenge, but I have to explain what the mapping of this innovation. Of course, when we innovated, you do it for different stages, a long mile, medium mile, last mile. I believe in this challenge we have the 3. because we have the track, and the track could be, the track in the end could be last mile, but we have a long mile because we have a cross dockings, and we change the plane because it must be a long mile because we have a scale. This is what we try, the features of we create a multi-dimensions cover, more or less. Nowadays the planes must be 140, 160, depends on the plane, it must be a special plane. We already qualify the solutions, so we are beginning a lot of qualifying in the qualifying process, but what I check here is we can resolve it this easily because we already have some do some tests with extreme profile for under the constants when we take 10 hours protection between 15 to 25. So I believe more than 6 hours protections could be, and we have in this challenge a mix of ambient temperature or temperature control. The only problem I can see here, but you already study and have answer for that, is that the tarmac. The tarmac is it when the planes are parking, and it's a problem for thermal train because it's higher temperatures and the influence of the motor and the floor is incredible. Sometimes we are more than 50 degrees, and this could be a problem. But when we develop this, we have a possibility to give this prototype with a reflect that reflect, and we could be the tarmac if it's not to be more than 5 hours could be not a problem. Just to show, sorry, we already studied as I say in the first we have a double protection if you use the active cold. It could be in track, could be however, and in cross docking. This what we have in this challenge. We have 3 cross dockings. Is the chance between the airport handling and the first airplane. We have the tarmac. You have a problem, but you have to use reflective cover, and then the airplane. I believe it's not a problem because normally we have temperature control, and in 50-25 we can do it. And when you get the airport, you have another cross docking. I believe this cross docking it's ambient temperature, but normally this is a fast move. I don't see a problem, and I believe in this case you can have a cool dolly. Cool dolly is it's a little track that can collect from the plane with temperature control. If you have it, it's good because we don't have excursions. We don't have reasons to have an excursion. And then you have the track in the end. Maybe are going to do the last mile. When you develop the solutions, sorry, one of the things that we try to do it is mapping the routes to see the potential that we can have. Here I can talking about Europe. As you see, Europe, we can make these routes easier. You have routes, in yellow is the routes of 10 hours, in red is routes more than 20 hours, and in red it's 5 hours. In 15 to 25, I believe we can do it, all of them. The only thing it's important is in sometimes use temperature control, but 20 hours could be not a problem. If you have routes, and I don't know if this challenge is in Europe, but if it is in Europe, it's not a problem. As you can see in these routes, most of the routes you can do it in 5 hours, and I'm talking about Lisbon to Athens, Dublin to Rome, Brussels to Oslo, so it's not a problem in hours. I believe the camera can answer easily this. If they need, international route, depend on the route, because if you have 10 hours, it will be the same that I already said in Europe, because 10 hours is not a problem, and you know, in the airplane they use temperature control when the pharmaceutical goods being the plane. So I believe it's not a problem. Just to know, Pronto, we already compare the standard camera and the others, and one of the things we try to do it to put color stripes in identification to simplify the logistics, because it's too important. When you collect goods in these cross dockings, you must know very well and very identified which range of products we are handling. And in this case, we are it will be this orange, and we have to use and to organize it to the manner to don't have problems in this all this stage. And there is an important thing in this cover. We use PCM and PCMs. Normally, we can use it in active, cold, temperature control and ambience. It's not a problem, and they can do all the operations with no variations and no executions. Thank you.
Thank you so much, Manuel, for your presentation and for letting us know the solution. I would then ask Ana Magalhães, in this, looking at the science behind all this solution, what is the importance of the materials used? Can you explain it to us?
Hello, everyone. The synergy of materials for this type solution is crucial for us to obtain a solution with high thermal efficiency. A small change in materials make all the difference. This is where CENTI, Center for Nanotechnology and Smart Materials, participate. It is an institute of the new, I'm sorry, I can, next slide. Okay, I'm sorry. It is an institute of new technologies with multi-sector orientation, equipped with cutting-edge technology that promotes activities of research, technological development, innovation, and engineering in the fields of smart and future materials and systems. Founded in 2006, it is the result of a fruitful cooperation of 3 universities, 2 technology centers, and 1 institute of the new technologies, all recognized for their national and international relevance. CENTI is based on 3 main areas: functional materials and solutions, smart materials and systems, plus design and engineering. CENTI explore advanced technologies enabling the development, testing, prototyping, and scaling up of solutions for the market, as is the case with the Smart Cover PCM. CENTI play an important role in these developments due to its transversal skills and the technologies in the different stages of development of innovative products with customized functional properties and improved performance, namely in the R&D strategy for the development of multi-layer structures, with the thermal management properties using different textile materials and the phase change materials. In addition, CENTI can perform several tests in order to evaluate the performance of the innovative product, both during its optimization and the final validation in a real environment. In this project with APP, the main goal was the development of solutions for thermal management using phase change materials, which improve the thermal performance of the covers and increase the versatility and the level of integration of this solution in this APP product line. Our contribution was the development of the layer with PCM. Thus, we start with the selection of promising materials, namely 3D textiles and no-woven structures with high thermal insulation, as well as polymeric materials. In this selection, their costs and their performance were considered, and we determined their chemical and physical properties, namely their thermal properties and their absorption capabilities. Oh, I'm sorry. Regarding the phase change materials, the chosen one was of vegetal origin based on oleic acids, taking into account its thermal performance and its sustainability. After selecting the materials, the layer with PCM was built and their performance was evaluated. This evaluation was carried out by approximating the experimental simulation to a real scale. The tests were performed in a climate chamber where the structure with PCM was placed outside the product package, and over time the temperature was monitored with the data loggers. The temperature profile followed were those of Hafnar winter and summer. The potential of PCM layer in the cover was evaluated, and the structures were compared between them, with and without the PCM layer. The results showed a significant increase in the thermal and energy capacity when we use this flexible layer of PCMs. For the most critical profile with high temperatures, Hafnar summer, there was an increase of 7 hours of conditioning until the system reached thermal equilibrium when compared to the cover without the PCM layer. Regarding the Hafnar winter profile, it reached 15 hours of conditioning. Considering that this simulation was performed with heating package, the obtained results were very promising, and in the future they can be better. This is the simple and sustainable science behind this product. Thank you very much for your attention.
Thank you, Anna, for explaining us how the materials used provided us with a sustainable solution that can be reused once, and of course, critically maintaining the temperature of the goods that are shipped with this solution. Of course, monitoring the temperature and tracking the shipment is also a very important part of thermal chain maintenance from SmartKAI. What was the solution, the technological solution development, and what its importance in monitoring the shipments? Albert?
Okay, can you hear me now?
Yes, now I can hear you.
Okay, sorry for that. I'm working with SmartCAI, and a company that was founded by Stefan Braun several years ago. He's doing thermal engineering for more than 20 years. And about 5 years ago, we introduced the thermal packaging software, which allows you to simulate the temperatures within a thermal packaging just on the computer. And since about 2 years, we are working exclusively on the virtual cold chain software suite, which is the following. There's basically several modules, and the core module is the thermal packaging software, which we call thermal packaging, and it allows you to define a simulation model of your packaging solution and your payload. And when you then give an outside or an ambient temperature profile, you can calculate, the software will calculate the inner temperatures of the payload or your sensors that you have in the packaging system. This is very useful for designing your thermal packaging systems. You can, for example, check how changes in the geometry or the materials will affect the performance of a packaging solution. It will allow you to check whether a given packaging design will work for a given payload or a given temperature profile, because you would have to check that for changes in the payload and the temperature profile as well. There's typically not one single solution which fits all, but you have to recheck whether some combination will work. And what you also can do is, for example, to check what is the best choice for the conditioning of cool packs, and something that you basically can only do with the software, and which would be very expensive or nearly impossible with just experiments, is to check how robust is your packaging solution when you have changes in your specification. For example, typically there is tolerances in sizes, there's tolerances in material properties, and if you're interested to analyze how these will affect the robustness of your solution, then you can do this quite easily with software. So there's a lot of things you can do when you have a virtual model of your packaging system, and that is a great help for people who are designing thermal packaging systems. But there's even more that you can do when you have a virtual model of your packaging system. You can, for example, do a scientifically based risk assessment by, for example, creating all the historical temperature profiles for a given lane for the past few years, and then run that virtual model against all these temperature profiles. And what you will get out is the temperatures inside of the package and the payload temperatures. And by checking whether they are in the allowed range, you can then decide whether that shipment would have worked or not. You can discriminate failures from passes, and you will get real numbers for this comparison. Because we can calculate these numbers of failures, we can also go one step further and do something that is, I think, also quite unique, because we can then calculate the total cost of ownership of different packaging solutions when used for a given payload on a given lane. So you can compare how much everything will cost. I will show a short example soon. So for just the core package, which is the thermal packaging software, you have to define a model, which is basically a bit like Minecraft or a Lego model, where you define bricks and their material properties, and then you will get a virtual model of your packaging system. You have to define the payload and all the components of your packaging system, like PCMs, like insulation materials, and also what is important for the cover especially is the surface properties of the cover, which decide how well it protects against radiation from the outside, like sun exposure, and also something like hot tarmac will radiate onto the surface. And all these effects will be correctly treated by the software and go into the results of the payload temperatures. You will then have to define an outside profile. You can do this in a tabular way, or just like it was done here, you import from some measurements, and then you can run this profile against the model that you defined, and you will get out the temperatures within the packaging system. So you typically would define some positions where you put sensors. So when you do experiments, you probably wouldn't put that many sensors, but because everything is virtual, it's just as cheap as a mouse click to define all these sensors, and you can then see how the temperatures within the payload would evolve. And in that case, you see that the gray lines are between 15 and 25 degrees, and up to something like 32 hours, everything will be okay, and then some of the sensors will be out of the desired temperature range. You can see that a calculation like this is not trivial. It will take about 3 minutes, and that is a typical number that you typically have for such a calculation. Now, for the risk assessment part of the software, once you have these models defined, you can, for example, compare several versions. These are just some covers that are made up. They are similar to the original smart cover, but they are not exactly the sizes and material properties are not exactly the same as they are. I just made this as an example to show what you could do. And in this case, we compare a palette with no cover, a palette with a smart cover, but no PCM. And then we have compared the 4-degree PCM and the 20-degree PCM. And we want to compare their performances for a lane which goes from Moreira to the airport in Lisboa and then to Sao Paulo and some final destination near to Sao Paulo. So you see that you define your lane in a very simple way. You just say where it is, for how long, and then you can either give a constant temperature for when it is under controlled temperature conditions, and when you're, for example, on the tarmac, there's typically no temperature control, so we can give the temperatures as they would be measured on that airport, and you define, for example, that there's sun exposure possible. And with that information, our software will then generate a lot of profiles as they would have been seen if you would have sent a shipment on that lane in the last 2 years. And you can see here that it's about 1,000 historical profiles that are generated. And what we now do is we run these 4 models against each of these profiles. And then as a result, we get how many failures we get for each of the solutions. And you see that the version with the PCM, either 20 or 4-degree in this case, will pass completely for all month. For the cover with no PCM, there are some failures, especially in June and August and in the winter month. And without the cover, you would have failures in every month. So you get quite detailed information about how you can expect your packaging solution to perform. And last but not least, once you have these failures, you can give costs to the packaging solution itself, to the transport of it. They are different weights, so the transport costs depend on the weight and are not the same. Then you have typically some costs for the excursions. And if the excursion is bad enough, you lose your product, which also causes costs. And if you take all these costs together, you get a total cost of ownership. And you see then that in this case, the 20-degree PCM, which is not no surprise, really is the best choice. And you can also get the numbers for how much more expensive the other solutions would be. So this is basically our software suite, and our contribution was to provide this software suite to the engineers at APP and also give them support in how to use the software. So I think that's it for me. Thank you for listening.
Thank you very much, Albert, for your contribution for this presentation and for explaining us the digital technology that's behind it. So I would ask now Professor Cristina Silva and Beatriz Bernardes, how did the contribution and the partnership with Universidade Católica materialize on the development of the solution, and what were the main goals of this partnership?
Good morning to everybody. Are you listening to me? Yeah, thank you. So I was very fortunate because I had the opportunity to be contacted by APP, who asked Catholic University of in Portugal to do consulting work in this project. So the main work was that I helped the most was on the optimization of the thermal performance of the solutions, a cover solution that APP was meanwhile developing. So the main objective was to try to extend the transportation time within a certain temperature range. And for example, for pharmaceutical materials between 2 degrees and 8 degrees and other ranges. So I did work together with Beatriz and also in collaboration with all the team in IPP, namely João Santos, Nuno Meireles, and Manuel. So with the knowledge I have on transport phenomena and heat transfer, we try to study together with Senti what would be the best materials to prolong the shelf life. One of the things is to increase the resistance, thermal resistance of the materials. So in order to, this is a picture of how it works. So if you have in one side a high temperature, for example, if you are distributing in a tropical region, the material of the cover should avoid that this high temperature arrives to the product. So as it is shown here in the picture. The other option was is to include PCMs, which is called also clever thermal mass. The PCM is a material, there are different PCMs, but here the option was to use PCM between solid and liquid. So the solid, when we supply energy, the solid rises its temperature until arrives to the phase change. During this phase change, the temperature is maintained relatively constant until it is the solid becomes all liquid, and then the temperature increases again. And as you can imagine, with this solution, it's possible to keep the interior of the cover at a reasonably stable temperature. And this works, so I gave the example of a tropical region, but this works also on the opposite, because some materials cannot go to temperatures lower than 4 degrees, 2 degrees Celsius, so it works also in the same way. So it's like the PCM absorbs the energy and delays a lot the response of the system. To optimize the process, we have constraints. So we wanted to have keep a very useful volume, so we could not have a very thick cover. The weight of the cover cannot be too much to be easily assembled by workers, as it's shown in the lower picture. And so also the cost of materials, we look into it, and to be eco-friendly. I helped also together with all the team to use the SmartKAI software and take profit of all the advantage that Albert already explained. So we had a range of different materials, and with the SmartKAI, together with all the team, we were collecting properties of all the materials, including in the software, and simulating what could happen under different solutions. So this is where it comes the optimization, because of course if we can put a lot of PCM, we can easily extend a lot the transportation time at a constant temperature. So we try to arrive to a good solution with a good balance of materials that would not be, for example, too expensive. And based on the calculations and estimations that were provided by SmartKAI, we gave information to Senti. So we did all this, it was really teamwork on how to prepare the interior of the cover with the right PCM or right amount of PCM. And this is more or less what my contribution, and I can pass the word to Beatriz that can show then what was done after.
Good morning, dear Hal. During the development of this project, several tests were performed to evaluate how the materials used in the cover will improve its performance. I show you in this presentation the ultimate test that was made in the thermal chamber test, comparing smart cover PCM with a standard cover for a product temperature range of between 2 degrees and 8 degrees. The test was made in the same conditions, the same external temperature profile between 23 degrees and 30 degrees and with medium load, and were used 6 temperature resistors in each cover at the same position in each cover. The initial temperature product was at 4 degrees, and the test started. Based on the results, it's possible to verify that the smart cover PCM has a better performance. The worst point, the worst point was at 5 hours 50 minutes for the smart cover PCM, and comparing with the standard cover, the time was less. So the cover maintained the temperature between the 8 degrees during 3 hours and a half. The best point obtained in the smart cover PCM was 16 hours, and the standard cover was 8 hours 40 minutes. So this test shows us that the smart cover PCM improved the performance, as a better performance, and now APP and the team of APP will need to make more tests to improve, to see how the smart cover needs to be improved to take a better performance and to maintain the temperature range between the limits, that's the range limit. So I don't know if you have any question, but for me it's all. Thank you.
Thank you so much, Beatrice. We will have questions. We do have questions already for our speakers, and we do have questions from the audience. I would remember that if you want to ask a question to a speaker, you should share it on the Q&A, the chat bot here, and direct it to the speaker you want to ask the question. But my first question will be to Manuel. How did partnering up with multiple institutions help in the innovation in thermal chain? Why did you go this way to find innovation and not do it by yourself in APP?
No, it's very easy to answer, because if you only do in your company, you are trying to be commercial, and this is the important part. And using specialists like Senti, Católica, and there is another guy that it was a guy that died in this project. It was Joaquim Tutor. It was a specialist in nanotechnology and materials. It's completely different, because we are always looking for very good performance, but with this kind of synergies and specialists, we can get, we can pay or have, we can get for new materials, new experience that are already being developed, and also we get time using these specialists, these situations. And there is another thing too important, it's completely different, it's more credible, because it's not APP talk for a cool PCM cover, it's all of the specialists, using Smart Kai is too important because, as Albert explained, you have the tools that it can check all the results and simulations. In the other customers, they do every day. So I believe it's quite important to create a group of the institutes, companies that can be put our innovations and new solutions more credible and accept most of the new ideas that these institutions are every day. So for me, it's completely clear. You need a specialist and to help to get the solution.
Thank you so much, Manuel. Ana Magalhães, we spoke about this briefly, but I would ask you again, how important is or was the choice of the right materials in ensuring the thermal capabilities of this solution, and why did you choose these materials, and why are those so important?
The right solution is almost always based on the right choice of materials. For thermal properties, the ability to retain or release energy and the thickness and the area of the materials are of the extreme importance. Porous and fibrous insulation materials should those be considered as they are capable of absorbing high amounts of energy. In all areas, the future of materials is based on their natural and sustainable origin, their production, their use, and ultimately their recycling process. Regarding the thermal chain solution, the materials will be increasingly lighter, more flexible, and obviously with a great capacity for thermal energy management.
Thank you, Ana. So I would come back to Manuel because we have a very interesting question in our chat bot. It's when will the product be available in commercially for fourth-party logistics and third-party logistics companies? Will you commercialize it? Are you already developing the process? I imagine we're still developing all the process of patenting it is, because it is
Of course.
let us know, what are your thoughts on that?
As a company, we want to develop as soon as you can. Of course, we are talking now about the prototype, but we are very anxious to put the solution in market. As you know, at the moment we have a pandemic stage in the world, and this distribution vacancy could be a very good opportunity. I believe Discover, very well done qualified, could be a possibility. I'm just talking about Portugal. We have 5 hours by truck to every ARS, is the regional states. Could be a good possibility. But now we are focused in the production, see what the production, more qualifying tests, and I'd love it to be maybe in October, in the end of October. This is one of our goals.
We also have this long question also includes an idea of pricing, but I expect you have this covered up in the future.
I'd love it not more or less than 1,000, but we have to check.
Okay. So sorry. Go ahead.
We integrate here a system that you can monitoring and traceable for all the places you use it. And it takes times, and we are now with this system that we begin with the cover. We're already using in important customers, and we can adapt easily in the cover. So, and it's answer to your what cost will be the cover. I believe for me it was important, depend on the quantities, but one of the goals is less than 1,000. But it depends of the qualifying tests, of the materials, depend on a lot of things. But this is one limit that we try to do it.
Thank you. Albert, focusing on the technology used and the simulation software, how beneficial it would be this for a company to keep up to analyze the results using the simulation software in the design phase of the solutions? What are concretely the benefits? You showed us a bit on your presentation. Can you explain more?
Well, I think the benefits are, of course, huge, but this is why we made the software. There's basically two things that you can gain. One thing is that you don't need to make a measurement, an experiment for every change that you think would be benefitful. So you can just try it out with the software. And one thing that is sometimes underestimated is that you can try out things that would not even be possible with an experiment, because either it would be too long, too expensive, or because you don't have the material. For example, you can try out materials that don't exist. You just define something that doesn't exist and see how much would that help. And then if you learn that it would help a lot, you can look for a material which has these properties. If that is not possible, then you at least learn something. But there's a lot of things that you can do once you have a virtual model. And I think even early adopters like APP are just learning how to use the software to its full potential. Just to mention that the car industry has started, I think, in the 70s using virtual models for engineering. And it is since then a very common tool, and I think all the cars that we are using nowadays are only possible in that case because they are virtually developed. And I think the industry of thermal packaging just can make the same use, and it has tremendous advantages, but it has a bit of a learning curve. So I think we are not yet seeing the full potential.
No, okay, I'm sure of it. I'm sure we can still understand more about the potential of this software. Manuel, again for you, you're being bombarded. Does the PCM layer, does the cover covers all the box, meaning including the bottom of the box? And also a second part of this question. Can we reuse the product for different transports? How reusable is this product?
No, this is we develop a system to be many times reusable. Related to the PCM, there are PCM all over the cover. Could have in the bottom. At the moment, this prototype don't have in the bottom, but as all of the part have PCM. It's the only way to have a homogeneous result and performance. So, I mean, I think I answered to your question.
Yes. So, and now Beatriz Bernardes. Were the tests made just without load or with load, so you could look at the impact of temperature in the product?
The tests were made at different loads. So normally are made with a maximum load that it's full of product, with minimal load and a minimal load. So we made the 3 loads as possible to see how the loading change and the product and the cover performance. So we made a lot of tests with different initial temperature products. We see if how the coverage, how the performance is using an initial temperature of 2 degrees, 4 degrees, or 8 degrees, for example, depending on the temperature range, the product temperature range, but are made all the possibilities in the tests. So
yes. So in the bottom, yes. Professor Christina, in your opinion, how can the partnerships between academia and private organizations be drivers for innovation? How, in what way can these work as a driver for innovation?
Maybe I shall try to answer, giving you a better explanation or making the connection of what have been discussed now. So, because I'm not sure if it was clear. So there is the smart guide that all the advantage, the software is quite sophisticated. It provides a lot of solutions and complex solutions. But the result is of a model is never better than the data we put in the model. And this is the contribution that somehow me with Beatriz made, that we take the software, but we have to identify what are the materials that Senti helped, but then what are the really properties, the input data of this software. Then we did some experimental tests to verify, because a model to consider all aspects is quite complex, and sometimes we have to assume certain values because they are not available in the literature or difficult to estimate. So we did all this study, and then with relatively few experiments, we validated that the software was providing good estimations of the reality. And based on that, now, for example, APP can, if a client asks to have, for example, longer time, it can consider to produce a cover with more PCM, for example, or so easily can do some simulations and see if it's possible to develop new solutions. So it is somehow with the knowledge, theoretical knowledge. I had already knowledge on modeling, so that's why I also was able to integrate quite well with the use of the smart guide. So I was I would say the person that helped to transfer the potential of smart guide to the practical application in APP. I don't know if Beatriz agrees with me. This is, I think, is one of the contribution that an academic can give, for example, to a company. Of course, if a company has already some expert, because some companies have before IPP had an expert, a previous academic on nanotechnology, as Manuel mentioned, but this person died, so I came and I was able to do so. APP, in fact, had already contacted a person with a PhD level, because it has this capacity to help on innovation on this aspect.
Thank you. Thank you. And I have a new question for Ana Magalhães. In regards to thermal chain solutions, what do you think the future holds regarding the materials to be used? You're in mute. Yes, now.
Yes. These questions I have about a little in the before questions, but the future of materials is based on their natural and sustainable origin. Through their production and I mean their use and ultimately their recycling process, it's very important. Regarding the thermal chain solution, the materials will be increasing lighter, more flexible materials, and obviously come with a greater capacity for thermal energy management. This is the example for the PCM cover That's the app development.
Okay. Thank you, Anna. Albert, another question that I think already was somewhat covered in your presentation, but again, I will reinforce it because, well, there are questions. How can the use of a simulation software like the one you developed help a company innovate in the thermal chain?
I think the main purpose is that you can try out things much cheaper than when you have to build everything in experiment. So if you have an idea that something would work, you can try out whether it works, and if it works, you can put efforts into making this real. If it turns out that it doesn't help, then you don't waste any money or effort in a solution which will not provide the gains that you want. So I think that is basically the most important thing, that you have faster innovation cycles, because of course it is much faster to run a simulation for 5 minutes compared to prepare an experiment, do the experiment. And if you have a product which is protecting your product for 12 hours or 24 hours, then you have to do a 24 hours experiment before you know what the outcome is. And if you're serious about making measurements, you would actually have to repeat that measurement to be sure that everything went right. So that is a lot of time that goes into this. It also is a lot of costs, of course. These thermal chambers are not there for free. So you can just cut down on your costs and speed up your innovation cycles. And you can try out ideas that you probably wouldn't try out if you would have to pay the full product. So I think that is the most important thing, and the whole topic is not so different to other industries where simulation is used to great extent and to a great advantage of the people who are using it. So I think there's a lot of things that you can gain.
Okay. Perfect. Thank you for your answer. And Manuel, we have a lot of curiosity regarding when will this product be available throughout Europe. So we mentioned before that by the end of the year, maybe we'll have it. Will it be throughout Europe by the end of the year?
Yes, we are trying to do. For us, it's too important to do this process of qualifying and production. Mm-hmm. And as Christina said, we can have more protection, more PCM in the second step. So this is, we're presenting a prototype. I believe the result is good. It starts like a dream, but I believe it. I can share with these people, and it was in the end, we feel it like that. And as I said, now it's a problem of more qualifying tests and focus in the right production, get the reflective material for tarmac, because we already know it's a problem in these operations in planes, tarmac, because it's very used, and with this pandemic problem, we must be fast and agile. So for me, I'd like to say it's tomorrow. For a company, I'd love to say it's tomorrow, is when we have the conditions to be with the price that we able to the people and the customers buy, with comfortable and reusable. But I believe as soon as you can, maybe end of October, maybe we begin to sell.
Thank you. And I would ask you now if you want to wrap up this session and thank all our participants and the partners.
Okay, thank you. BP would like to thank all of the panelists, Sofia, Anna, Albert, Beatriz, Christina. This is an innovation lab. In the past we do presential, now in this new way we do like a webinar. I think is a good way too, because we can get to over the people that have interest. This is an edition for the thermal chain innovation. And like the specialist will help us to explain this whole process better, Here we can see Cristina, Beatriz, but there are more people that are involved in this process. And I'd like to this opportunity to thank everyone who watched this new format that allows us to reach everywhere, and also thank Loyal Advisory and Mojo Brand for organizing this webinar because it's more professional. And I leave the invitation for next Monday. We are going to have another opportunity to see the South American addiction version with different challenge and experience. Another people in panelists, but in experience in the other side. And I think it will be speaking and debating that we have managed to improve our new thermal chain challenge, is the goal and the mission of our company. So thank you so much for watching this webinar, and it's a pleasure for APP and all of you. Thank you very much.
Thank you, Manuel. And also I would like to thank all our speakers today, Cristina, Beatriz, Ana, and Albert, for sharing their knowledge on the science behind this intelligence solution, and also all our participants again for being here, for asking questions, and many questions, which is what makes the webinar interesting, is the discussion. Now we will end with a short video that will show you in a more material way what is the solution, the intelligence solution we are speaking about. But before that, I will just say to all our participants that we will be sending a short survey to all of you. It would be very good for us if you could answer this survey so we can improve and do a better Innovation Lab Talk next time we talk to you in European editions. And if you want to join us next Monday in the South American edition, of course, please do so. Just register for that. Thank you very much. Thank you, and bye-bye.